Hello, my name is Sai Kumar. I'm here to explain my ICP4, that is Python course. So I've been given these 4 programming tasks to do. First task, to find the correlation between the survived column and the 6th column, which is given the Titanic use case. So the Titanic use case in the class. So they asked me to describe, do we need that feature? Let me show you the data first. So this is the data which I have been provided with. So this is a column, 6th column, which we need, and the survived one, which is present with 1 sign, zeros and ones. So let me take you to run the code. So this is my code. This is a code which has been provided in the class, and I have added this line to print the probability difference between people who survive, and to separate the sex classes, that is female and male. So let me run the code and show you how it is being predicted. So here you can see female people is being survived of almost 74% when compared to the male people, which is of 18%. So this is the thing which we can derive the correlation between sex and the survived column. So next one, implement the naive based method using scikit-learn library. So I've been asked to implement a naive based method using the provided data. So the data which is given is the class CSV. So this is the data which we are given. So this is a code. First thing which we do in the code is like directly read the CSV file into the DF. So total data in that CSV file is being stored in the DF, and only the type DF, only the column name type is being stored in the Y variable. So later on, except the type variable, remaining data is being stored into the DF1. That is by dropping the type column. So type column. So we have splitted the train and the test set, that is this data set, according to this percentage. That is, test set is given almost 15% of the given data, and the remaining 85% is given to the train data. So we have declared a model, that is Gaussian naive Bayes method model. So using that model, we will train a model depending on the train data, using the train data. So these are the train data which are provided to the model, and it is being trained. So later on we will predict, that is Y prediction, using a model.predict method present in the Gaussian naive Bayes package by providing X test set. So this test predicted amount, like the value is being this model.predict method returns the predicted probability. That predicted probability, or predicted accuracy, is given with around some 10 digits. So I've used this round method to round out the accuracy and print it. Let me run this program and show you the more. So this naive Bayes accuracy with is produced around 60% of data. This percent accuracy is not constant. It changes every time because this test size, that is this 15%, always changes when we run this program. Let me show you by running this program, and again you can see this, again the test accuracy has dropped to 51.52%. Third program, implement linear SVM method using the same scikit library. I've used the same program to get the data. I parse it. Sorry, I separate the type column and separate the remaining data except the type column, and split the data. Split the data using train test split method, and here comes the main part. We have used this SVC. SVC is a package which is present in the SVC package. So I have initialized this SVC function to the SVC so that I can using the training data. So later on, the predicted value is being stored in the y predict, and this is being printed using after rounding it to the 2 digits. Let me show you and run this program. So here comes the accuracy, which is of 77%. As I said, this accuracy is not constant. It always changes when you run the program, because the trained data and the test data will always be changed when you rerun the program. As you see, the accuracy is dropped to 68%. Using the SVM with RGF kernel on the same data, so with the same model, but RGF kernel is being introduced in this. So as I showed, it is the same program. We just introduced the kernel as RGF. So let me run this code again. Show you accuracy. See, this one got of 70% around. Its accuracy is not constant. You can see the change. Look, it has been increased to the 75%. Almost 5% is being improved because the trained data and the test data are not constant when you run the program. Well, thank you.